Sure it's wrong? Oh, I'm missing a 2, haven't I?
Yeah.
Yeah.
Is that right?
Yeah. There's a 2 missing in the middle. I need a pencil to remind myself to fix that, because I keep forgetting to fix that one. Okay, so what's next then? Next one?
Can you go over questions and limits? Because I can open my bank account at last.
Well, I can certainly do an example. Just tell me which one. Have we watched the video?
No.
Ah, then request denied. Because I need you to make some efforts to catch up yourself. And then, certainly, if you're still having trouble after watching the video, then I'd be happy to. But I don't know if the rest of the class would necessarily benefit as well from seeing that, because it's just because you missed the class. Do you get what I'm saying? So if you watch the video and you're still thinking, no, I need some examples, then we can do that. But until then, I just want to prioritize other people first. And if there's time today, we can do some examples. But I just want to prioritize the rest. So, questions?
Oh yeah. Page, we're going to go back. Page 18.
Fine, yep.
This is the only page that, no matter how many questions I answer, it's still solvable.
Right, which example do you want?
3, from section 3.
Okay, anyone?
Yeah.
Anyone at all?
Anyone.
So, I will do...
W.
W?
Yeah.
Okay, W. Page 18, 3W. Okay, can you go to that page? Page 18, 3W? Should only take the attendance. Oh, attendance sheet. This is HS2, isn't it? Michelle, there you are. Abir, there you are. Autumn. Autumn.
The girl, she's not.
Oh yeah. Oh, okay. Celine. Yeah. Sophia. There you are. Mubarak. Yeah. Oh. No, Chidera. Mohammed.
Yeah.
No, Sabrina.
She's on the way.
Oh, is she? Moza. There you are. Angela. There you are. Ahmad. And Safra. Okay, so I'm missing 3 people. Alright. So if you can watch carefully, guys, if you can watch this one, I should give you a little hint. There's definitely one of these questions in the exam. So, let's see. We're saying 3W. Okay. 4k minus 5. Yes?
Steven, you know there was this time where you told us to mark some would be in the exam, some would not be in the exam in our books?
Yeah.
Yeah. Does that also account to the midterm exams or only the NCUK exams?
Only the NCUK ones.
Okay, so that means everything can be in the midterm.
Everything and anything could be in it. Entirely dependent on how I feel. Okay. Alright. We're told that this has 2 real roots. So, what does that tell us? Yeah. What's that called? Yeah. The discriminant should be positive. that means the b squared minus 4ac, b squared minus 4ac should be positive. Yeah? So that means 64k squared, and then 32k plus 4 minus 4 times 16k squared, and what's that? 12 minus 20 is minus 8, I think, minus 15. That should be positive. 64k squared plus 32k plus 4 minus 32k squared plus 32k plus 60 should be positive. So the k squared, oh, I wrote 32, but I actually meant 64. Because what will happen is that will cancel with that. So you'll get 64k plus 64 is bigger than 0. So then you'll end up with the answer k should be bigger than minus 1 in the end.
But doesn't that mean that k could be 0 which means it has 1 unit?
K could be 0. Hey.
Bigger than minus 1.
Oh yeah, there's one value I have to exclude. I should say it here. K not equal to 5 over 4, which is a possibility because I said k is bigger than minus 1. And why am I saying it's not equal to 5 over 4? Why am I saying k is not equal to 5 over 4 in my answer?
Because will it cancel out A?
Yeah.
Oh, so then
So if it cancels out the a, then it's linear. Yeah, and linears can't have two roots. Yeah.
Wait, when you square the first bracket, where did the 32 come from?
Sorry, yeah. Where
One sec,
did
what?
you
Dude, he is literally asking me a question. Chillax. Go on.
When you squared the first bracket, minus
Yeah.
8k minus 2,
Yeah.
you got 64k squared.
Yeah.
And then I understand the plus 4, but where does the 32 come from? 32k.
Oh, it's the 8 minus 8 by the minus 2 twice.
Oh, okay, because you. Okay, man.
Now, what were you asking about?
I was asking the same question.
Okay, so you see a little bit of patience and a little bit of listening to get your information.
But I still don't understand the not equal to minus 4. Shouldn't you say not equal to?
Not equal to 5 over 4.
Yeah, 5 over 4, yeah, sorry.
So I don't want this guy to be 0.
So we have to check.
Oh yeah.
If we don't, and we don't put in that answer,
Well, it's wrong because I asked you the values of k that make this have two solutions. And linear could never have two solutions, so it is quite wrong of me just to leave the answer at this, because this isn't true. Because if I said, okay, what about 5 over 4 then? You're like, oh, well actually no, that's only one solution. So it does need to be both of these, this and this. If you were to write that as a set, it would look like this. Minus 1 to 5 over 4, not 5 over 4. And then 5 over 4 to infinity. That's what it would be as a set. So it's basically from minus 1 onwards, but you skip over 5 over 4.
That's union, right?
Yeah. And actually, this actually gives me a good idea.
Steven?
Yeah.
Sorry, but how do you get 5 over 4? I understand all the way to k raised to minus 2 minus
You look at this, and then you ask yourself, what would make this 0? What value of k would make this 0?
Oh yeah, 5 over 4.
Yeah. And you understand why it can't be 0, right? Or not?
Why k cannot be 0?
No, why this part can't be 0. Why 0 here is bad. Why is 0 there bad? Like, well, what's such... No, because if it's the 0, then there's not quadratic.
Oh, yeah,
It's
yeah,
linear. Yeah.
X squared.
Let me show you something here. Can someone just read back the quadratic? What was it, please?
4c
Yeah.
5x squared
Yeah.
plus -8 -2.
Minus 8.
Yeah, -8 -2
Yeah.
x. Sorry.
Minus 8k minus 2x, like this,
Yeah.
as you can see.
Plus 4k plus 3.
4k plus 3. Now, I can't ask the computer to graph this because it doesn't know what the k is. So let me put in the value of k and then graph the quadratic. So having a look at my answer, what type of quadratic would I get if the k was equal to -2? How many roots do you think I would have? No, look at the answer we just got.
-2 would not have.
-2 will not have any roots. Yeah. So if I put in -2 for k and graph this, I know I do have 2 roots. Oh, maybe I mistyped something. Is this 4k minus 5 minus 8k minus 2? Ah, silly me. What did I mistype here? Yeah. Okay, let's try that again. Sub in -2 for k and graph this. Goodness sake. Sub in for k minus 2. There we go, there's our quadratic. And graph this. So you see it has no solutions. Yeah? Okay. Tile vertically. Right, let's put in another value of k. What happens if I put in k is, let's say, 5?
It will have 2.
It should have 2. Why should it have 2?
Because that's what our equations what we found out.
Yeah, it needs to be more than -1. So let's see if that story checks out. Now, I might have to zoom out because it could be quite large. Oh, jeepers. Oh, for goodness sake, sorry, I'm being very tired today. Let's try this again. I haven't drank much of it yet. Sub in 5. There's our quadratic, and let's graph this guy now. There, 2 solutions, okay? What do you think might happen if I put in -1? What do you think might happen if I put in -1 for k? Maybe not no solutions, but maybe one solution, because it's at the boundary between the 2 possibilities. So, let's see what it looks like. You see? One solution.
But something I don't understand. We know that if the discriminant is less than 0, it has no
Yeah.
solution.
Yeah.
But the k is not more than or equal to -1, it's just more than -1.
Yeah, that's my point. It needs to be more than -1 for 2 solutions. So if I make it equal to -1, then I'm at the boundary of having 2 solutions. So what's the boundary? What's the boundary between having 2 solutions and no solutions? Well, having 1 solution. Now, this is much more interesting. What did I say k can't equal? 5 over 4. That's 1.25, right?
Yeah.
What happens if I put in 1.26? How many solutions should I have? 2. And 1.24? 2. 2. Yeah.
Oh yeah.
Because it's more than -1.
Yeah.
Oh,
Yeah.
It's not 1.
But what about 1.25?
1.
None.
None? Or maybe 1. But certainly not 2.
Yeah.
Not 2. So what is happening? It has 2 solutions, then all of a sudden it doesn't have 2 solutions, and then it goes back to having 2 solutions. So to help you see this, let's put in some values. So let's put in a value nearly 1.25. So we'll put in something like 1.3 for k. there's my quadratic. Let's graph it. Now I'll need to zoom out a bit. See, it has two solutions at like 0 and 60, roughly. Okay? Now, what happens if I put in, no, not there, in here, what did we say, 1.25, was it? 1.251. So how many solutions? Two, yeah. Now, this looks like 1. It looks like a linear, doesn't it? But maybe if I zoom out. The other one's at 3000. Now, let's see what happens when I actually do put in 1.25. I'm not sure. I think it might just become linear. Oh, thank you. You were trying to warn me. This is called Derive. It's an old maths program that the previous maths teacher used, but it's nice and easy to use. Okay, let's plot this. Now, can you see it in blue? It's linear, isn't it? It crosses only once. If I zoom out a bit, I can kind of really see this more. It is. So what happens is, as you're changing the value of k, you're changing the shape of the quadratic. And as it gets closer to 1.25, the quadratic kind of, can you see, you're almost like pulling it out. Like if I was to put in tile vertically, let's put in just one more before we finish this for k.
So if it was 1.26, you're going to push it back in.
Back into more curve. Yeah, like if I put in 1.2501, this is practically 1.25, but it's technically not. So it should still have two roots, but it's looking more linear. So if I put that in for k and graph it, can you see it there in black? Now I have to zoom out even more. You see what's happening? As you approach the 1.25, it's like you're pulling out the quadratic. And then what happens when you hit 1.25? It becomes linear. And then when you pass it, it gets curved back in again. Yeah.
If you pass it under 1.25, go back.
That's a good question. If we're a little bit under, yeah. So like if we have 1.2499, let's actually see what that happens. I'm not sure. Let's see. 1.2499. Graph. It's upside down. Yeah. So it starts off upside down, and then you stretch it out to linear, and it's linear at 1.25, and then you start stretching it back in. So yeah, it is. You were right to think it's kind of like it's upside down, and you bend it to a straight line, and then you bend it in like that. Yeah, this is what's nice about the graphing programs, because it can help you visualize what it means to have the k changing in the quadratic, and it helps visualize what it means when we say we can't have k equal to 1.25. Yeah. Okay. Right. I thought that was quite interesting. So what will we have a look at next now? Yeah, will we do some limits? Because I'm sure some people might have problems with limits. Yeah. We can have a look at limits now.
The first one is
Which page? 20? Which one?
I.
Which number?
How many digits I? Oh, number 5.
20. Question 1.
No, question 5.
5. Ah! Didn't we do this one?
Yeah.
Didn't we? But I can do it again. No problem. And then we'll do some limits after this. Okay. Right.
You doing 5i?
Do you know what? To make this a little bit more interesting, I'll prove it a different way. Because last time I did long division. Yeah? Yeah? Because, yeah. Watch this now. Okay, so let's say we have Sn equals A plus AR plus AR squared, etc., 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 up until AR n minus 1. Yeah? Or Sn equals AR plus AR squared, what's the next one? AR cubed, all the way up until, now what's the last one here? AR, because they're all increased by an R, okay? Subtract. So now I have Sn minus or Sn equals AR minus AR is gone. AR squared minus AR squared is gone. Gone, 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 gone. Except for the last one and the first one. That's equal to A minus AR n. So you have you have 1 minus or times Sn equals A minus AR n. So Sn equals that over 1 minus r, and I'll take the A out, so that's A 1 minus r n over 1 minus r. Okay. Yeah, so now let A equal 1, or equal x, and also x is some number between minus 1 and 1.
Sorry, is this like progression?
Yeah. I know what I'm doing. This is the last one on page 20. And then let also n go to infinity. So if I go back here, I get s infinity equals A is 1. This is 1 minus x power infinity over 1 minus x. Now what is x power infinity if x is a small number between minus 1 and 1? What happens? What do we think? Like imagine x is 0.5. What happens if you keep raising the power? It decreases. It goes to 0. So this will be 1 over 1 minus x. But remember what s infinity equals. It equals a. What's a here? 1 plus AR. Now what's a? 1. And what's r? So what's AR? X. And what's AR squared? So therefore 1 over 1 minus x equals 1 plus x squared plus dot 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 dot. See? I know what I'm doing. Now I do like this proof better than the other proof I gave you when we did it in long division, because this proof makes important the fact that wasn't clear in the previous one, and that is this formula we got, that's actually only true when x is between minus 1 and 1. A fact that we did not mention when we did it using long division. Because we didn't know. Yeah.
How did you come to find, when you wrote that A equals 1, R equals x, and minus 1, x is between minus 1 and 1?
Yeah.
So where is that?
I just made a choice for these values, you know. Like for example, suppose I wanted to do something like prove something silly like 1 plus 1 equals 2, and I had this formula, 2x equals x plus x, for example. Well, this is a formula which we know is true. 2x is equal to x plus x, right? So then I can say, okay, well, we'll just use this formula with values of x equal to 1. So we get 2 equals 1 plus 1, you know. So I'm using a formula from GP, and I'm making choices of A, or, and x, you know, so that it can match up with what's in the question here. What don't you understand now? What step was confusing?
The range.
Yeah, the requirement for that is
That's
if,
the only thing that I don't understand how you
if when we did the GP lesson, we said that we can only use the infinite sum formula if or is between -1 and 1.
Yeah. Because otherwise it will become infinite.
Yeah. So if I'm going to call or the same as x, then the same restriction on the x, there's the same restriction on the x as there is on the or. You're not happy with this. Why aren't you happy with this? What's wrong with it? You now have two wonderful proofs of this. You have the long division proof and the GP proof.
Can we do a remainder theorem question?
Mm-hmm. Which one? Which page is that?
22.
What page?
22.
Which one?
No, I don't want the question, but like from question 3, I don't understand what you mean by in each case state what the remainder is by using the remainder theorem.
Yeah.
I'm not long division. I don't understand what, yeah.
Put in the value of x to get the remainder. So like in 3a, just make x equal to 7 over 2.
Oh, okay. Okay, can we do from question 6?
No. Number 6 isn't in any exam.
Oh yeah, I wrote 1 to 5, but I thought it was from the midterm.
No.
Okay, then question 4.
I tell you, for the midterm, yeah, we should do number 4. Which one?
Which other questions must we do for the next?
Ah, that be telling. That be telling.
You might as well just pick D.
4D?
Yeah.
Okay. So, you're told that px cubed plus 2x squared plus x plus 6, when it's divided by x plus 1, the remainder is 3. Yeah? So, p minus 1 cubed plus 2 times minus 1 squared plus minus 1 plus 6, that should equal 3. So minus p plus 2 minus 1 plus 6 should equal 3. So that means p should equal 6, 8, 7, 4. Yeah.
Or you equated x plus 1 to get x equals minus 1, you substituted into the...
Yeah. Easy peasy, lemon squeezy. Yes?
Page 40, number 10.
Page what?
40, number 10. Right.
Ah!
What is A and I?
Now we're able to do this one because we did E yesterday. Yeah.
That's why I asked you.
Oh, I thought you were talking about one from the practical lesson with the logs.
No.
No, sorry, I misunderstood you. Yes, we can do that one now. Can I scroll down? So, page 40. Question 10. So, you have the sum of a half en plus a half e minus n. That's equal to the sum of a half en plus the sum of a half e minus n. That's equal to a half sum en plus a half sum e minus n. Now, where does the n start? Starts at 1, doesn't it? And it goes up until what value? 10. So this is e1 plus e squared plus e cubed, etc. up until e10 plus a half, and then this one here is e minus 1 plus e minus 2 all the way up to e minus 10. Yeah? Now this is GP and this is GP. And this is GP with A equals what?
1 by 2.
No. No?
1
It
minus
was 2.
No, it does not.
E.
Oh, forget about the half.
Okay.
E, yeah. And what's the or?
1? No.
N
Yeah.
plus
So
one.
what am I multiplying by here?
N plus
Yeah.
one.
And here, what's the A?
Minus E.
Yeah, e to the minus 1. And what's the or?
E.
No.
Minus one.
No.
Minus one?
Yes. Yes. So,
Why minus 1 again? 1.
the powers are decreasing.
Yeah, I know.
Yeah.
But,
So e minus 1 times what gives me e minus 2.
okay.
Yeah. So this is a half a 1 minus or n over 1 minus or plus a half a 1 minus or n over 1 minus or minus. And that's the answer. You could probably clean this up a little bit. I don't know. Do I bother at the back? Oh, I'll actually give it as a decimal.
So we're supposed to do this on calculator, right?
I guess so.
Sorry, can we do
Can you make it smaller?
the page 28?
Mhm.
Thank you.
28.
Yes.
Yeah. Which one?
I went to like one of I did number 2, like number 3 or number 5 or something. Just with the R C and the N. I don't really.
I could do one from number 3 if you want. Which one?
No, you just put that in there. Okay,
That's what you want. I assure you, none of these cause problems for me, so it's which one do you want?
M.
In number 3?
Yeah.
3M. Okay. Can I scroll down? Not yet? Okay. Well, when you're ready, the next thing we're going to have a look at is page 28.
I'm not sure where this is in the book, but when we're sketching, when we're solving quadratics and cubics, how do we find the maximum and the minimum?
That's with completing the square. Oh, cubics! We haven't done that yet.
What about quadratics? What do we do?
So for quadratics, yeah, if we complete the square,
We can get the vertex, yeah.
yeah, which one is the vertex? The one right, you know, there's x plus or x minus something, and then we have one number outside the bracket. So
Yeah.
which is
The one in the bracket.
that's like the x plus
Yeah.
something.
Yeah.
So that would be the maximum or minimum point.
For the x value for it, yeah.
And the one outside is what?
The y.
Is y. Yeah?
The y value of the vertex. Yeah. Okay, can we look at this one now? Yeah. Okay. Minus 7 less than or equal to minus 2. Minus 7 less than or equal to minus 2x plus 17 less than or equal to 7. What should I do first here? What should I do first?
You take out 7.
Not the 7. 17, yeah. I do minus 17 on everything. So the effect is to cancel those two. So I have minus 24 less than or equal to minus 2x less than or equal to minus 10. Now what do I do? Yeah.
Make them
You divide both sides by minus.
flip the sign
The-
and change the
Yeah, what's the verb? What am I doing? Over, yeah. So now I get 12 greater than or equal to x greater than or equal to 5. Now you're also told x is a natural number including 0. So what are the natural numbers between 5 and 12 and equal to 5 and 12? Well, that's 5, 6, 7, 8, 9, 10, 11, and 12. There are the x values there.
So, if we mistakenly put this bracket in form of in the shape of the closed form.
Yeah, you mean like if you were to write something like
Yeah.
5, 12 like this?
Yeah.
What's your question?
Or like we put 5, 6, 7, 8 for put the closed bracket.
Oh, nobody's ever done that, so I have no idea what I would do. You mean you write the answer like this, but use square brackets instead of curly brackets?
Yeah.
And there's more than 2 numbers inside?
Yes.
Then I'd probably allow it because only because there's more than 2 numbers.
Yeah, I know,
But if the answer was only 2 numbers, like suppose the answer here was 5 and 6, and you wrote square bracket 5, 6 square bracket, then no.
The stuff under in between.
Yeah, but now I would allow it because if you wrote square bracket 5, 6, dot 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 12, then I don't actually think you mean. I think you are trying to say that you mean the numbers 5, 6, 7, 8, 9, 12. Yeah. But the problem is that there was only 2 numbers, 5, 6. Now I have a confusion. Do you mean the numbers 5, 6, or do you more likely mean all the numbers between 5 and 6?
The one answer is that we put, like for example, I put 5, 6, 7, 8 to 12.
Yeah.
And then I put this square bracket.
Yeah, like this.
Yeah.
I would allow that as long as you had more than 2 numbers in it. But I wouldn't be happy about it. I'd be very unhappy about it, actually.
Sorry.
Yeah, go on.
But like this kind of question, instead of the n response 0, if we had like r or we had z.
Yeah. How would that affect the answer? Yeah. So let's consider in an alternate universe the answer, or you were told x is a real number instead. This is what you mean, yeah? How would that affect the answer? Anybody?
Yes, it would probably the close bracket 5.
Yeah, this would be the answer. 5, 12, like that.
So all numbers between 5 and 12.
Yeah.
So closed bracket is for all numbers between 2 numbers.
Yeah.
And open bracket is for the ones the curly bracket is for the ones you want to state.
Yeah, statement. Yeah.
Okay,
So how is that any different?
Wait, go on.
If it was z instead.
In this question, it doesn't change anything because the integers are just the positive, negative whole numbers. I'm not even looking at the negative numbers here, so I'm only looking at between 5 and 12. So this would be true even if I changed the question to say this, or even if I changed it to exclude 0, because 0 was never a consideration. So it's the same for all of those here.
But in general, what effect does z have?
It's the same as n. Yeah. It's just you're looking at positive and negative, but you're still stating the numbers.
Oh, you have to state it.
Yeah. Now you don't have to state all of them. You just dot dot dot. It's fine. So like you're going to say 5, 6, dot 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 12.
Okay.
What page is that? 46. Number 6. Yeah. Which one, Michelle? A or B? I'll do B. Page 46, 6b. So you have y equals minus 3e minus x. Now what you do is you need to compare that to this, a, e, b, x. So in this case, what is the value of a? Minus 3. And the value of b?
1. minus
-1. Yeah. So you can say A is negative and B is also negative. Now if you look at the 4 graphs I gave you, do you still have those with you? Yeah, look at the graph where I tell you what to do if both are negative. I think it looks like this. And this point here is A, which in this question is -3. And that's it. That's all I need you to do. Yeah.
Anytime B is negative, it's decaying.
When the B is negative, it's decaying to the x-axis. Yeah.
Our exam next week such that from the beginning to where?
The last questions I have on the exam, I'm asking you to sum an AP and sum a GP. So like, I ask you to calculate like S100 for an AP and then S10 for a GP. These are like the last, towards the end of the exam.
So we don't get to the indices anymore?
No.
We don't get to limits?
Can't remember if I put a limit question in it. I feel like I didn't though. I don't think I did. I'm 90% sure that there isn't a limit question, but I'm not 100% sure. Because I made these questions like 2 weeks ago.
Did you put the question for the Gaussian?
I can't really ask you a method because I'm just asking you to input the answer. So if I did have a simultaneous equation, which let's face it, given it's a maths exam, it's a likely question. I'm not going to say use the blank method because I have no way of checking that you did, you know. So the question would simply be solve. And that's it. Yeah.
Also, the exam we're doing is like question, give answer.
Yeah.
No need for work. Like you don't have to see the work.
I'm giving you some paper for working, which I'll collect up at the end, you know.
Are you marking the work?
No. You'll get your mark back once the test is over. So I think the test starts at like 2 o'clock. Yeah, the test starts at like 2 o'clock or something, or 1 o'clock, I don't remember. What time do we have maths on Monday? 2. You start at 2, and then it automatically closes at 4, exactly at 4 o'clock. And then once the test is closed, you can see all the answers. And your score then, yeah. And I let you try the quiz a maximum of 2 times in the 2 hours.
How much is the mark?
I just marked out 100.
For 20 minutes.
20 questions, 100 minutes, so it's 5 minutes a question.
Yeah.
Yeah. But when you retry the quiz the second time, I think I have it set so that all the answers from your first attempt continue into the second. So you only have to change the answers to the ones you got wrong. You know, you don't have to retype everything. Yeah.
Do you have the practical problems from page 44?
Not really. Like in my AP/GP sum question, it's not a practical problem, but I kind of state it in words. You know, so like for example, I might say something like, sum the first, I might say something like sum the first 100 natural numbers, or sum the first 100 even numbers. So take that example, sum the first 100 even numbers. What numbers are those? What are the even numbers? 2, 4, 6, 8. So what's the A? 2. And the D? 2. And the N? 100, because I said the first 100 natural numbers. So, or the first 100 even numbers. So, I'm not really giving you a practical problem, but I do remember stating the AP/GP problem in words. You know, like sum the blank numbers. You know, something like this. Yeah.
From what you were just describing, you said you give us 2 chances, right?
Yeah.
So the first chance, when you're done, do you see the questions you missed?
Yeah, you do.
Do you see the answers beside it?
No, because then where would be the fun in that? You'll just see if you got it right or wrong.
Okay.
So you can focus on the ones marked wrong
So
then.
you do it, the ones you got wrong again?
Yeah.
Wow.
Yeah. Okay. The reason I did this is because I feel like giving you that option compensates for any lost marks that you might have through workings. Do you get what I'm saying? So I want to make your Moodle quiz grade as similar to, like my goal, I have three objectives doing it this way, okay? Number one, you get the feedback quicker. Number two is less work for me to do. And number three, by letting you try the quiz twice, I'm trying to make your grade as similar to what it would be if you were doing a paper-based one. So obviously if you were doing a paper-based one, yeah, you don't get any marks for work-ins if it's on Moodle. So your marks go, I estimate that you might lose 10% because you might have gotten something nearly right, but not right enough for the computer. So I feel like you probably, my experience is students do 10% worse on Moodle quiz. So usually I just let them try the quiz once, but this year I'm letting students try it twice, so the ones they get wrong they can try again. So I'm hopeful that letting you do this will close the gap, so you won't be 10% under, you'll be on the same grade for a paper-based one, you know?
I actually really want to my homework. I said 32x,
Yeah.
I wrote 3x.
Yeah. And if you can see that it's wrong and you have it still written down, you can quickly
Yeah.
fix it then, yeah. Anything else now? What time are we at now? Now we'll have to wrap it up then. Okay, so I think I'll see you again later today, but just to remind you that it is a laptop you need to bring on Monday for the quiz. It needs to be fully charged because I won't let people use the plugs. Okay? You could use your phone, but I don't recommend it because it's kind of a pain to type on your phone. So I think it's better if you bring your laptop. Okay? And then if you like, then on the tutorial of next week, we could actually go through the quiz questions that you had trouble with then. Yeah. The other advantage of doing it on the Moodle is that I can actually see per question how students did. So for example, if everyone got question 5 wrong, then I know that's one I definitely need to do in the tutorial. Okay.